Hello, I'm Mr. Shrum. Oh, I'll click this out of the way. And I am back again with a mastery test walkthrough. And we're going to go through Newton's second law. Last time we went through the first law. That was known as the law of inertia. Objects wanted to stay in their current mode. So if it's at rest, they wanted to stay at rest. If objects were moving at a constant speed in a straight line, they wanted to keep moving at a constant speed in a straight line. Okay? Now we're on Newton's second law. And this is the F equals ma law. At least that's how I refer to it. So we're going to use this a lot. The force is equal to the mass of an object times the acceleration that the object is experiencing. Or you can rearrange that as A equals F divided by M, or M equals F divided by A. And in these problems, we're going to be asked to find the force, and we're going to be given mass or acceleration, or you're going to need to find acceleration first and then multiply by mass and then find the force. Or you're given a force and a mass and then you need to find the acceleration. Or you're given force and acceleration and you need to find the mass. You're going to use these equations a lot, so be prepared. So the first question. When a net force of 17 newtons is applied to a dictionary placed on a frictionless table, it accelerates by 3.75 meters per second squared. What is the mass of the book? Okay. So remember, I said F equals ma. Well, what information are we given? Well, we're given the net force, 17. So we know that F equals 17 newtons. We're on a frictionless table, and it accelerates by 3.75 meters per second squared. So we're given F and A, and now we're asked for the mass. So all this requires is plugging in and using a calculator. So we have 17 newtons equals m times 3.75 meters per second squared. Then you just divide 17 newtons by 3.75 meters per second squared. 17 divided by 3.75. Plug that in, and you get about 4.53 kilograms. Okay. And the answer is B. Okay, not too bad, right? Just plugging and chugging into that equation for now. But things are going to get a little trickier, right? Things can't be that straightforward all the time. This is a science class. So in question 2, we have a car with a mass of 1,000 kilograms. So M equals kg. Write that down. And then we're given its speed. So it's initially going at 22 meters per second. And then it stops. So final velocity is 0 meters per second. So at first it's going 22 meters per second. They hit the brakes. 3 seconds later, it stops. And then we need to find the force required to stop the car. Let me show you. Okay. So we have m. We have the initial final velocity in t, but we need f. So we need to first find A. And we know that acceleration equals delta V over t. So we'll take the final velocity minus the initial. All over 3 seconds. Plug that into your calculator like I am about to do. And you get 7.33 meters per second squared. And now we can plug and chug. So F equals ma, which equals the mass. We're given that from here, times A. We had to find A, but now we found it. So everything's fine. So F would be 1,000 times 7.33. That would be 7,330 newtons, or we'll say 7.33 times 10 to the third newtons. That's a negative acceleration, but wow. That's just telling you which direction it's going. The magnitude is the same. So that is the force required to stop the car. Okay. Cool. Number 3. What is the net force and acceleration of a ball of mass 0.75 kilograms? So we need F and A. We're given M, 0.750 kilograms. And that ball is subjected to forces 11 newtons and 7 newtons from opposite directions. So we can draw that out. We'll say 11 newtons are going this way, 7 newtons are going the other, and then the mass equals 0.75. So, stop sharing, show you what I got. Okay, so this little object, mass 0.750, has 7 newtons going this way, being pulled on it, 11 newtons going the other way. So the net force is the difference between these two values. So that's just 11 minus 7, 4 newtons. So we know the 4 newtons is the net force. And that would be in that direction, but we don't need that for now. But 4 newtons going that way to the right. Yeah. But depending on how you draw this, that would be different. But that doesn't really matter right now. All you need is 4 newtons for now. And now you use that equation again. F equals ma. Well, F equals 4 newtons. And the mass is 0.750 kilograms. Wow. So you just divide 4 by 0.75. Divided by 0.75. So A equals 5 point, let's say 33 meters per second squared. So it'll be 4 4 newtons and 5.33 meters per second squared. Wow. F and A. Cool. So that's the process so far. Let me get reorganized. So we're at number 4. With what magnitude of force does a ball of mass 0.75 kilograms need to be hit so that it accelerates at the rate of 25 meters per second squared? Assume that the ball undergoes motion along a straight line. Well, F equals ma. We're given m, 0.75 kilograms. A equals 25 meters per second squared. So now just multiply those together. And you get F equals 18.75. And you can just round that up to 19 newtons for this answer. Plug those numbers in, and that's what you get. Cool? Cool. Then 5, what happens to the acceleration of an object if the net force of an object acting on it increases? So what happens to the acceleration of an object if the net force on it increases? Well, the acceleration increases because the mass does not increase. So just looking at this equation, if F increases, mass stays the same, A has to increase, okay? So the more force applied, higher acceleration. More F equals more A. Because M is constant. All right? Six. What is the acceleration of a cabinet of mass 45 kilograms if Jake and Ted push it by applying horizontal force of 25 newtons and 18 newtons, respectively, in the same direction? Assume a flat frictionless surface. So we're given M, 45 kilograms, and then Jake and Ted are pushing that 25 newtons and then 18 newtons in the same direction. And then we're asked, what is A? So let's stop sharing that. All right, we have mass. The applied force would be 25 plus 18. So a way to simplify this, let's redraw it. 43 newtons going one way equals F, And now we just plug in those numbers. F equals ma. F, we know, is 43 newtons now. M is 45 kilograms. So 43 divided by 45 equals A, and that would be 0.95 meters per second squared. And that's the closest one we have right there. Technically 0.955555 meters per second squared, but you can round it up to 0.96. Okay, so that just composed of us adding the net forces and then dividing by the mass of the object to get the acceleration. Okay, moving on. What net force is required to push a sofa with a mass of 59 kilograms so that it accelerates at 9.75 meters per second squared? Assume a flat frictionless surface. So for 7, the sofa has a mass of 59 kilograms. So we have M. A, it's asking, what is F in order for it to accelerate at 9.75 meters per second squared? Well, we're given these numbers. That equation comes in handy yet again. So now it's just plugging and chugging. My favorite. And you can just use a calculator, of course. Let's check back with this. Okay. Well, this is in scientific notation. And 575 newtons can also be written or rounded up to 5.8 times 2 newtons. Okay, that's just in standard notation. If you guys need a reminder. So to get 5.8 back into this equation, 10 times 2, or 10 times 5.8 times 10 to the second power, excuse me, means you'll move this decimal point 2 times to the right. So 1, 2. And then you'll add a 0 there. So that decimal point moved from there to there. So that's 580 newtons. And that is close to this, okay? So that's just rounding and using scientific notation. Not too hard, just be careful. L is pushing a box of mass 7 kilograms with a force of 25 newtons. If the force of friction is 2.6 newtons, what is the value of acceleration of the box? So I think this one will be a little trickier for you, but it's okay. Just take your time. You're given the mass, 7 kilograms. Force. L is pushing 25 newtons worth of force. But you also have friction here, 2.6 newtons. And then you're looking for A. So best thing to do is to draw it out. So the object, 7 kilograms. Bam, there's the object. She's pushing it this way, 25 newtons. There's some friction going the other way, 2.6 newtons. The net force would be 25 minus 2.6. And that would be 22.4 newtons going that way. So now you have F and M. Now you just plug and chug. And then you plug that into the calculator, 22.4 divided by 7. And you get 3.2 meters per second squared. Okay. So draw it out, subtract the forces, and then plug into F equals ma. And there we go. These answers should be meters per second squared, but that is an momentum error. So these are, the units are incorrect, but the answer is still 3.2. So watch out for that. And then I'll finish up number 9 and 10 in another video because I need to go to another meeting, but I will be back to finish that up. So see you then. Bye-bye.